Hello, my name is Kapil Sugand. I'm one of the research registrars at Stanmore here. Myself and Mr. Van Duren and Mr. Westcott are running a trial on how to put in a guide wire for a dynamic hip screw. I'll show you how to do it on this machine, and we'll ask you to do the same thing, please. The first thing is, let me show you the screen itself. On the left-hand side, you see a model construct. There is a extracapsular intertrochanteric fracture, and through that you're meant to put a guide wire which is going to be as central to the head of the femur as possible. We call the central of the femoral head the apex, and your job is to get the guide wire as close to the apex as possible. On the right hand side we have several performance metrics which are measured in real time. We're going to measure the total time you take to do the procedure, the number of x-rays you take during the procedure, the total amount of x-rays you've taken during the procedure, number of retries of the guide wire. The most important thing, no matter what these measurements show, and the only clinically validated outcome in orthopedic literature, is the tip apex distance, and this was done by Baumgartner in 1995 in JBJS. The tip apex distance in his paper is 25 millimeters, whereas on this exercise it will be 20 millimeters. The tip apex distance is measured in two planes, both AP and lateral. What it means is the distance between the tip of the guide wire in relation to the apex of the femoral head, which is in the middle. As long as it's within 25 millimeters, the risk of cutout, according to the Baumgartner's curve, is going to be minimal. Anything above 25 millimeters, you're seeing an exponential rise in the risk of the dynamic hip screw cutting out. Okay, so that's the screen you'll see. Now, if I just show you the stylus pen, this is the Phantom stylus pen. You'll be doing everything with this. You'll be putting the guide wire, drilling, you'll be eventually, when you do the entire procedure, reaming, screwing things in with this. There's a button over here which you press for the action. The Phantom stylus pen can move in any direction you like, and you should hold it like a pen with the thumb overlying the button and continue with the task. Make sure you keep a hold of it because it does have a mind of its own and it will jolt, so don't be afraid, but do keep a firm hold of it. If you accidentally drop it, it will damage. It's quite sensitive. Lower down, there are two pedals. On the left hand side, you will get, if you press the left pedal on the left hand side, you'll get a shot of the AP, and if you press the right pedal, you'll get a shot of the cross-table lateral of your guide wire. You'll see exactly what I mean when we do the exercise. So, first things first, let me show you what you're meant to do. So, we'll do an attempt of a guide wire. Over here, on the left-hand side, we have the AP. Only when I press the left pedal will I get a snapshot of the current position. I'm quite happy with that. I'll go a bit further up, and that should do. And I'll make sure that I press the right pedal too, just to have a look at the lateral position, which I'm happy with too. So I'll have a look at both views and make sure that I try to get an optimal tip apex distance. The idea is to go as far as the subchondral cortex, so not penetrating through the outer cortex, but going as close to it as you can. And I'm quite happy with that position. Once I'm happy, I press enter, and I get a score of 11 out of 11. My tip apex distance, which is the thing we're measuring for each one of your attempts, is 11.1. Anything below 25 millimeters, there's a very, very low risk of failure and cutout. Thank you very much.